Agentic process automation. Simplistically, that is where agents are full participants in business processes. The agents are the nodes that execute the tasks or the work in the business process. Now we have tools, these large language models, the brains of an agent, that can actually understand documents and deal with the ambiguity. We can actually define the happy path and then provide high level instructions on what to do if the happy path deviates. A lot of those things we can actually embody within the intelligence in the LLM within an agent. These models can reason. They can do it over long periods of time, and they are remarkably effective and accurate. That is a game changer, which leads us to believe that agents are now ready to be full-fledged participants in the business process.
Eric, it's great to be talking to you again about the agentic mesh. On this podcast, I am so excited because we get to talk about what's happening this week as it relates to how we're thinking more strategically about enterprise agents. And I'm excited about this topic we're going to be coming to, and it's all about agentic process automation. Is there anything that's happened this week that you wanted to talk about before we jump in? I mean, so many mind-blowing things have happened, like the release of Claude Code, source code. That was pretty that was pretty big, but
No, I think
uh
I mean, things are changing every single day,
mhm,
whether intentionally or inadvertently, who
right.
knows? Never a dull moment, as they say.
Yeah, yeah, yeah. Well, so let's get into it. Let's talk about agentic process automation. It's something we've covered before, but this week we're going to talk architecture. What do we need to make this thing a reality? So I'm going to, without further ado, I hand it over to you to teach us what are the big boxes on the picture.
Sure. Well, let me start with a simple explanation. So, just to
Yeah,
recap from our previous discussions,
sure.
agentic process automation, simplistically, that is where agents are full participants in business processes. Specifically, the agents are the nodes that execute the tasks or the work in the business process. So that's what APA does. Now, what we're going to today is talk about the architecture for APA. So when we think about an architecture, we're not going to cover the entire continuum, but here's a few things that we will actually talk about. What
Yeah.
are the major components in APA and what do they do? And lastly, how do they interact to actually fulfill the objective that we just talked about?
Okay. And because I'm thinking about our listeners, I'm thinking, let's go back and say, why are we talking about agentic process automation? What is the gap it's trying to fill? I remember, and why we think it's so important. And I'll give you an opportunity to go first, and then I'll pile on because we had a great conversation in January about this. And I'll let you go first, and then I'll pick up the slack if there's any.
Sure. Yeah, sure. So businesses run through business processes. We all know that.
Yeah,
Whether it's a bank account open process, a loans claim process, or a health claims process.
right.
Business processes are the work engines for a business. Today, we execute those business processes using various different tools, business process automation tools or robotic process automation tools. There's a variety of these things, but here's the challenge that each of them have. For a variety of different reasons, they're brittle.
Yeah,
And they break relatively frequently when inputs are ambiguous, or you run into an edge case, or you may need, in certain cases, manual overrides or overrides based off
right.
of something that may be in an expert's head, but maybe not necessarily written down. So they don't handle ambiguity very well, and they don't handle edge cases. But here's the deal. When you define a business process, 10% is that happy path, what is supposed to happen, and 90% of it is dealing with the ambiguity in the edge cases. So That's why they're brittle. That's why they're expensive. That's why they don't necessarily work as well as we all want them to. So, where do agents fit in? Well, agents are built to handle ambiguity. They have their own, to use the term, intelligence. They are able to understand documents, whether it's a PDF, a spreadsheet, a text file, a Word doc, whatever the case may be. They have the ability to actually understand what's in that document, in contrast to, not to use this in a pejorative way, but the dumber tools out there, the standard libraries. They're just better at it. Now, so now we have tools, these large language models, the brains of an agent, that can actually understand documents and deal with the ambiguity. The second thing they have is, with this intelligence, is we can actually define the happy path and then provide high level instructions on what to do if the happy path deviates. In other words, dealing with those edge cases, dealing with the stuff that's locked in people's heads, a lot of those things we can actually embody within the intelligence in the LLM within an agent. So the proposition here, John, is that these things can deal with the problems that current technology and current approaches actually have. And we think it can do it pretty well.
Okay, I love it. Thank you for replaying that because every time I hear you go through it, I learn uh it deepens my understanding, and I think it deepens the understanding for people listening to us as well. And so I want to make 3 points about it that I just thought of as you were talking. And the first is I've been going to a lot of healthcare AI events, and they don't talk about business processes. They talk about workflows. And I've been in so many different sessions where they talk about the workflow that the clinician does in the clinic, or the physician, or the nurse. And so I think for those of you listening who don't know why we keep calling them processes, maybe it'll make more sense if you think of them as workflows and things that regular people do, or exceptional people do in their daily lives, in their clinics, or in their organization. The second thing that really stood out is what you and I have come to see as obvious, but maybe other people don't, is that agents can deal with ambiguity because they can reason about that ambiguity. And, this might seem remarkable if you haven't done it yourself, but for a lot of us, we've seen this narrative that's shown in the modern tooling that says, "Oh, I'm thinking about that, then I'm thinking about this, and so agents are developing heuristics about reasoning, and they're starting to understand is maybe the wrong word, but they're starting to appreciate how to deal with that ambiguity and reason their way through the process." And then the third thing that you said that I really think makes sense for why agentic workflow, agentic process automation makes sense is, how do you reason about what happens when it doesn't work? And so those three things combined are 3 points I think just really make the case for, wow, well, why haven't we been using agents to do processes or workflow automation? And so that's why I think it's really important for us to talk about it and go into it in more details. What do you think?
Yeah,
Yeah.
well, absolutely. I want to kind of touch on one thing. You had a really good question, like, why now? Why didn't we do it before? And I think
Right.
this this actually comes because I think, as we all know, there's something that's special that seemed to have happened, especially with things like Claude Code in the December January timeframe. But
Right.
rewind before that is we had machine learning, early stage AI, natural language processing in the old fashioned way. And what ended up happening is, what we found is these tools were good, but they didn't have sufficient, again, I put it in quotes, intelligence to actually meet the bar. When ChatGPT came out, we could start to see there's an inkling of opportunity that's starting to come true. But even then, they weren't good enough to be
Yeah.
full fledged participants in a business process. But as I mentioned, December, January 2026, December 2025, Claude Code came out, and I think OpenAI just shortly after, but the models changed the way we need to look at these things. These models can reason. They can do it over long periods of time, and they are remarkably effective and accurate. That is a game changer, which leads us to believe that agents are now ready to be full-fledged participants in the business process.
Absolutely. And because I was at another conference last night talking about reasoning systems, I also want to point out that there are plenty of things that AI agents cannot yet reason about in a way that's useful for us. But it's a fascinating time to be alive because everything, every form of reasoning, the discussions are getting kind of mind blowing. So, anyway, but back to our story. Let's talk about business process agents or agentic process automation and how we think about that.
Sure, why don't we dig into the architecture? So, as I mentioned, what we're going to try and do is in the architecture discussion, identify the major components and what they do, and then how they interact to actually fulfill and execute a business process. So I'll list the major components, and then we'll kind of drill through each of them individually. And I know you'll probably have some questions, and it'll
Oh
lead us in a good
yeah.
direction.
No,
so,
no,
so
I always will. And I ask you, do you want to start with a trivial business process that we can all sort of keep in the back of our minds as you're talking about these components? Because I think when I think of business process, I kind of think of this abstract thing. And I don't know if other people see it the same way, but I see like, a graph and I know you're going to talk about them, but what's a workflow or a process in plain English? Do we want to talk about the bank account open and
yeah, yeah,
anchor it in that? Okay,
let's do
cool.
the bank account. So bank account open. I think it's something that everybody intuitively understands. Everybody's probably opened up a bank account at one point in time. And we're
Okay.
going to make it really simple. We're not going to talk about complex things. We're going to make it really simple.
Yeah.
And this is the process, some of which is automated and some of which requires human intervention. But a
Right.
bank account open process, think of that as the umbrella for four macro level tasks. The first one is identity verification. When John wants to open up a bank account, the first thing we do is we got to verify that John is John. So we look at his driver's license or a passport or whatever the appropriate identification actually is. Once
Okay.
we can confirm that John is John, what we're going to do is we're going to actually do what they call a know your customer, which really says, do we know enough about John so that we can actually recommend the right products that match his risk profile, and a variety of other things. But they want to make sure that when they provide advice or guidance to you or act on your behalf on this bank account, that they know what your instructions are, if you will, or your
Yeah.
risk profile that guide them. So identity verification. Then what you do is you do the know your customer. Let's assume that you have everything you need to up the bank account. So the next step is open the bank account and put some money into it. So that initial deposit. The last step in the process, again, we're dramatically simplifying, is once we've got it set up, or got the money in the account, what we should do is notify John that the account's open, but also start to send him statements. So,
Right.
so that's the simplest way of
Yeah.
describing a bank account open process, and that's what I think we're going to anchor on it. So now,
Okay. Good. So let me just repeat 4 steps. Step one, ID verification. Step two, KYC or know your customer. Step three, opening the account, making a deposit. And then step four, notifying that the account is open and sending a statement.
you got
Okay.
it.
So that's the 1 through
Uh,
4. I get it.
So we think of this as kind of a serial process. Step
Sure.
one, two, three, four, 4 steps. When you start to get a little bit more complex, what you have is you may have, A, then B, and then depending on what the output of B is, I may call C or D, and then depending on where I am there, I may call E and F or G and H. So we're getting to alphabet soup. But you can see that if processes in the real world are a little bit more complex, what they
Right.
have is they have nodes that are joined together by the process flow and the information that's sent between them. That that process flow is what we call a DAG, a directed acyclical graph. And what
Yeah.
that really means is you have a start point and end point, and there's no repeating capability. It flows kind of left to right is the simplest explanation that I can give. So what we have is this. Envision a node diagram flowing across a page, a graph or the DAG, and that is the definition of the business process. So that's the first thing to know. We need to define it, and we define it in this notion of a graph. So once we have that, the next step is how do we actually go about executing that? So now I'm going to list the components, but that was the basis. So now I have a graph. I need a process manager that will go and execute those tasks in the prescribed order. I need agents who, if you think about that graph where you have each node, which represents some work that needs to be done, an agent is attached to each node in the graph. Once I have the agents attached to the nodes, I have to set up a way for them to actually communicate. So we have a communication fabric that lets them talk to each other, or at least minimally talk to the process manager. We have a few other components, a deployment capability, Kubernetes, for example. But fundamentally, what this APA is trying to do, it's a collaboration framework that allows agents to actually talk to each other. And in our case, this is where the coding or the personal agents fit in. When we wrap these things into with enterprise grade capability, containerize them perhaps so they can run in Kubernetes or elsewhere, what we actually have is today's coding agents or personal agents, Claude Code, for example, or Codex, their API version, potentially even OpenClaw, but we'll put that aside for a second. There's a lot of challenges with that. But what we have is today's agents acting as intelligent nodes in this process. And that is what agentic process automation is at the highest level.
Okay. So it's a graph which represents the process or the workflow. That's the path we follow. There's the manager of that process and the agents that execute the process. There's the agents themselves, which are the nodes or the steps, and they got to talk, communicate. So I know I've over trivialized it, but I like getting it down to the gross simplification because what you've done and what you're able to do as a great architect is you're able to create these abstractions for us to follow how you're thinking about a complex series of agents operating at scale. Okay. So great. We've talked about that. Now, do you want to tell us a little bit more about how to think about one of those components, or can I ask you some questions? You tell me where we want to take the conversation.
Well, why don't we start with questions and then I'll
Okay.
launch into my architecture discussion.
Okay. Well, so for me, I'm an abstract thinker. I often get into philosophy mode. So I'm going to not try to be that guy today. I'm going to say, anchor this into something concrete. And so when I think of this, I, you know, I don't want to think of this process running independent of all the systems. I want to, like, I'm a real bank. I got a real website. I got a real app, right? So when I sign up and do ID verification, I'm doing it in the branch, or maybe there's an app for that, and or the website. And so when you talk about these processes in the abstract, it feels really abstract. And so how do you add to this APA conversation the actual systems that you're communicating with, right? Because people aren't going to just throw away everything they've got. They're actually going to need to use the systems they've already got. And, at a lot of those banks, they're mainframe systems and maybe a web front end. And, it's a grab bag, as you know, having been a chief architect at a bank or so. Um, so, dude, can you anchor this process that you're talking about in how we should thinking about it from the systems that run the business now? You just sort of fill in the blanks there?
Yeah, sure. So if you think about the end-to-end process starts with identity verification. So
Yeah,
the first step is, as we mentioned earlier, let's just say that you need a driver's license or a passport, for
sure.
example. And let's just say that today you can go into a branch and you could actually provide them with that identification. And they're probably going to scan it and it would go into some system. Okay.
Yeah,
And that system would be the entry point to the business process. It captures that information. Now, maybe it's not necessarily, you're in the branch. Maybe, and I think some banks actually do this. You can take a
yeah,
picture of your driver's license and you can take a picture of your passport or whatever's relevant for their rules and regulations and jurisdiction. And that kicks off the process. So how the process kicks off may be quite flexible, may be done in a
yeah,
bunch of different ways. But either way, that information, that document, whether it's a scan or otherwise, comes into a system,
yeah,
and then the first step in that process is to actually initiate the bank account open process, which would kick off the very first task, which is the identity verification. And that agent then gets the information, the driver's license or the passport picture, and it goes about verifying that identity. Now, there's a few steps in the process, obviously. The first step is, I need to read that picture and actually get the various fields of information. But then there's a few other things it probably needs to do. It needs to figure out, based on the information I have, do I need more information?
sure.
Can I actually read all the information? Let's say it has everything. Then it needs to go to an identity or service provider that will verify that. So maybe, and
Yeah,
depending on your jurisdiction, Experian or TransUnion or LexisNexis.
yeah,
If you're in Europe, it's probably different. If you're in Asia, it's very different, I'm sure. So there's a little bit of thinking around how we actually go about doing that, depending on what the circumstances are for that particular identity that you may have. So that's the first step. So got the identity, it goes to the agent. Agent figures out how to go and verify it. It says it's done, and it would hand off to the next step. You have a question, John?
yeah. So, but, or, and, so where I'm trying to get to is if that's working at your bank today, and we're not doing systems integration, but I feel like where we're positioning agents is as the intelligent way to integrate systems that might not currently be integrated. So, for example, that company Persona we were talking to, they have a backend, an API you can call, you take a photo, or Experian has an API you can call. And so most companies have already got a maybe not as deep as a bank, but a know your customer process, or at least the sorry, let me not confuse the two, the ID verification process. So when we think about agentic process automation, we're not saying that you need agents to run every step in the process, or actually, no, no, you say it because you would tend to say things more thoughtfully about how we should think about integrating this concept of a process into our current systems, right? Do you want to say a little bit about that without
Yeah, sure.
boiling the ocean? But I
Yeah,
just
no,
think it's important to connect agents to endpoints and things that already exist and what doesn't exist. And
yeah.
uh, y-
Let's deal with a situation where there may be some ambiguity. So,
yeah,
um, most people, when they go into a branch or when they're doing it online, they would have valid identities. So, perhaps a passport or a driver's license. I know there's a, at least in Canada, and I can't speak to the US and other regions, but there's a desire to get lower income folks into the banking system, potentially even homeless people, so we can sign them up for social security benefits and such like that. These are, broadly speaking, the unbanked. And the
yeah,
reason they're unbanked is because they may not have the appropriate identity
yeah,
verification papers. They may not even have a valid address. So the question is, how do you actually deal with that? Today's bank account that serves people who have the appropriate identity verification, the documents, that works smoothly. But when you start to get into areas where they're not the happy path, where you have exceptions to the situation, where you may not have all the stuff that you need, and you need to figure
right,
out, what do I actually do next? So there's two ways you can
right.
do it. That's where a person comes in. So there's people in this
Uh,
process potentially, but a person knows how to deal with that. They would, based on either experience, or they could read a standard operating procedure, and they would then go, you know what? Hang on. I just need to go
yeah.
talk to my branch manager and see what I can do to help you out. That is what a person
Yeah.
does. We can embody the agents with that, perhaps not perfectly yet, but the same level of thinking that should be able to streamline the process better than it would be better than the answer saying, well, you haven't got enough information. We can't even help you. So we can do
Uh,
better than that.
okay. Now, so I think that's brilliant. And I'm glad you chose an example that forces us to think, not because we're advocating a particular point of view, but rather we're saying that there are exceptions to every rule. And when you get into a situation where the happy path, as you call it, doesn't work, wouldn't you like an agent to reason over the situation with the right context so that it can take an action that a reasonable human would have taken and allow it to reason on what to do with that exception?
Absolutely. I would add to that though, too,
Yeah, yeah.
John. So when we think of people in a branch or a bank, is I love these people. I used to work in the
Yeah.
in the bank. I know these people and they're wonderful. But here's the thing is as smart and as wonderful as they do not know, in detail the 800 standard operating procedure
Yeah.
documents that actually needs to be done. But here's the beautiful thing. Maybe we could use an agent that could digest
Yes.
that knowledge and actually use it and help the people to actually make the job or the task work smoothly. So this is a situation where there's a great augmentation. This is where we can actually give people a superpower so that they
Yeah.
can actually facilitate a process they may not necessarily either understand, be trained for, or, have done often enough to be comfortable with.
Yeah, no, no. I think what you're getting at is really important because I think about in my hometown in Canada, I was back opening an account and the guy at the front was brand new. And I was like, hey, man, congratulations. You got a job at a bank. It's a tough time to get jobs. And you can't possibly know everything, but isn't it nice if you could have a way to talk to some of the exception cases? You're at the front. Banks want people, humans need humans, right? It creates empathy. We want to talk, some of us want to talk to humans and for our banking operations. And, uh, I like what you're saying. It allows that focus on the personal connection instead of learning all of the syntax and rules of every particular crazy system that a bank has to follow. So I think we've landed that. I really appreciate us doing a deep dive on that. What is an exception is, I think, and I think you've addressed the other question as much as we need to, unless you want to say more about how to think about the systems in a bank. But I think you did a really cool job with that too.
Good. Well, I think yeah, I'd like to move on to the
Yeah,
next piece of the architecture, which we talked
please.
about agents. So let's talk about the agents that are actually operating in the
Yes.
bank. So I'm gonna use as a baseline and a reference, I suppose, is Claude Code.
Sure.
So Claude Code has all the capabilities that we talked about earlier. It's fantastic at reasoning. It can deal with ambiguity as well as most people could. It's pretty darn smart. It can, pass the bar and who knows what else it can actually do. So it fits the bill that it's the ideal candidate to think about and something that probably most people that would be listening to this podcast anyway may have some experience with. So think of an agent as Claude Code. Okay. And it's obviously the API version, but the Claude Code has access to skills. Those skills define the capabilities that it actually has. Okay. And Claude Code can access tools. Tools allow it to invoke actions. It allows it to interact with the outside environment. It allows it to call those systems that we talked about, perhaps using APIs or other mechanisms. So what we have is an agent, Claude Code, that has all the capabilities. the skills, the tools to actually do the work in any particular step within that overall process. So that's crucial. We now have the intelligence, the skills, the capabilities to allow agents to participate. So the next thing is in the architecture is the communication fabric. So now I got these individual agents. They're not very good unless they can actually collaborate. And they need to collaborate perhaps with each other, but more importantly, they definitely need to collaborate with the process manager. So think of the process manager as the thing that actually runs the overall execution. It executes the DAG. And the way it does that is every time, once it gets kicked off, it looks at the first task, the identity verification, issues a request to the agent that is in charge of identity verification, effectively says start. Then what happens, and this call goes over this common communication fabric. Then what happens is the Claude code agent will actually start that task, and then it emits information progress events that say what it's actually doing. So it will tell you that I've started the process, okay, or started the task. I've started this tool. This tool call's finished. I'm invoking this skill. The skill's finished. And oh, by the way, I finally finished, and here's the output. All that goes streams in real time to the process manager. And what the process manager can do with that is twofold. One is it can determine when the process is started, when it finishes, and hence when it can kick off the other ones. But it provides visibility into what's actually going on with the agent at a granular level of detail so you can actually see what's happening. So every one of these individual events that the agents emit give us visibility into the task and hence the process. That's absolutely crucial. And I would argue it's a missing piece of the puzzle, at least the granularity we're talking about, missing piece of the puzzle in traditional business process automation or RPA. So the communication fabric lets the agents talk to the control plane, the process manager, and it lets them talk to other agents. Now, the next piece, and we typically, by the way, we use NATS, which is the communication fabric commonly used in Kubernetes. It's global scale. It has, and we think it's particularly useful. It has a proven record of scaling to, to huge volumes, huge number of nodes, but it also gives you a global namespace. So all of a sudden, as opposed to when if I were to try and configure these agents as HTTP endpoints, I have to do a bunch of network plumbing to make that work. What I have is a global homogeneous communication fabric, global homogeneous namespace that allows all the agents to actually have a consistent naming convention, but actually find each other. So those are kind of the key things that we think are required in a communication fabric. We use NATS, but there's other ones out there. You could use Kafka, for example. But as you can see, there's two architecture approaches that we use that NATS comes with. Well, there's three, but we use two of them predominantly. One is the publish subscribe pattern. So because these things, these agent requests could take long periods of time. When I say long periods, it could be a minute, could be an hour, could be a day. The publish subscribe mechanism allows you to actually send a request and then subscribe and wait for a response. Very similar to event streaming. So that's the architecture pattern that we think is actually probably the right one if you want to do agents at scale. NATS is one of the tools, Kafka and other things, Redis, for example, and there's a variety of others that are out there that may be do just as well. However, and this is kind of the last piece of the puzzle before I break and stop talking, lag and ask a
Yeah.
question, but NATS also comes with a persistence layer where every message that comes in and every message that gets streamed gets logged to a persistent database. That's called Jetstream. So what you can do with that is particularly useful. So obviously, an agent isn't going to work perfectly 100% of the time. When it breaks, you need to have all the instrumentation so you can actually see what's going on. And you probably want to go and replay those transactions or requests to see what actually happened. Jetstream provides that. It's a persistent layer, so you can see all the requests and all the messages that were streamed back and forth literally in any level of detail. And it lets you actually replay those so you can actually see the interaction, the timing of these interactions in a fashion that allows you to do problem diagnosis. I've talked a lot, John, but those are kind of some of the core foundational architecture components that we think are required for agentic process automation.
Love it. So just going to summarize and replay what I heard. Agents, obviously have the brain, but they have skills and they use tools. That's helpful to know if you're new to agentic process design or agents in general. The other thing you said, which is strategic, is that agents need to communicate with each other and with the manager. And you talked about NATs because that's the standard in Kubernetes, but it could be any other of those eventing platforms like Kafka. You actually talked about a way in order to communicate, you need to know. Hey, I want to talk to Alice in HR, right? That's a naming convention. But you refer to other specific naming conventions to define the space of names. What is the namespace? And so I think that's super critical. And then you talked about the only way to debug such a complex beast would be to be able to look at the log of the communications between the agents. How far did you guys get before you spun off into an endless loop and stopped working? And I think all of those concepts are important as we think about agentic process automation and how this comes back to everything we've been talking about with this idea of agents operating in enterprises. This is part of the discussion and how we think about that architecture. Very cool. I'm glad we covered this because I think our discussion of APA has evolved very specifically and has been hardened over the last few weeks and months as we've been talking to customers and we've been doing implementation work. Anything else you want to add to the conversation?
Yeah, I think there's just one, maybe two more topics, and I think they're
Sure.
crucial because we highlighted them previously, but it goes without saying that if agents are going to do real work in real enterprise processes, they need to be trusted. That
Yes, trust.
implies a whole bunch of things, but from an architecture perspective, trust starts with identity.
Yeah,
We need to actually know who is doing what so that we can actually determine if they're doing it well or not.
yeah.
So identity. But once we layer on identity, we get authentication, we get authorization, role-based access control, we get discoverability. We can find them now that they have an identity. We get observability. We can see what they're doing because we know their identity. So the key there, and by the way, those are all the foundations of trust that we talked at length in previous episodes. So I won't drain it. But once you have those, you have the basis for what we believe is crucial. We put all that stuff under one umbrella. It's called enterprise grade. Enterprise grade agents running in an enterprise grade agent ecosystem that is implemented as form factor is agentic process automation.
Love it. Let me replay some of that with some of the new language I've been using out here. So, this trust foundation for agents includes what everything we talked about in the trust framework, and we say this is what enterprise grade means. And we talked about identification of the agent itself. And I remember having a conversation yesterday where somebody said, "Well, how do you who's responsible or who's accountable when an agent fails?" And I said, "I'm glad you asked. How do you do it in an enterprise?" "Well, you need to know the employee that did it." And I said, "We even joked about KYE, know your employee." And we said, "Well, if you delegate authority to another employee, they'd have to have an ID." And so I said, "Yeah, we did a podcast on know your agent." which is similar to KYE. So that foundation of trust has to start with an identifier of that agent. We also talked about agents have roles and they must be authenticated and they must be governed with access control. And there are role specific privileges that could be granted to them. And so that's an area that's evolving. How do you do that at scale? And we'll come back to that as that evolves in the market. And you also said that part of this trust framework is knowing or finding other people or other agents in this case that are findable. And so I'm glad you said that because we're starting to see a convergence of these individual topics that are coming together in the industry so that we can actually create an APA. We can actually start to build these at scale in a systematic way. Right now, we're doing it bespoke. Because you wrote the book and because you've been a forward thinker, you can frame all of this stuff as if it's self evident. It's not. That's why you had to put it in a book. And that's why I try to detangle the wires that you'd explained to me. And that's how we see it evolving. But you had another point you wanted to make. I don't know if you've lost track of the last thing you wanted to say, but you got some
Yeah.
space.
Well, the only last thing I would say is I've talked to a whole ton of people. And once you have all this stuff set up, the question that's come up is, okay, I get all this. How do I deploy it? Because today I
Yeah,
run
yeah,
Codex coding agents on my Mac Mini or whatever the case, or on my
yeah.
laptop, whatever the case may be. So there is a big difference between coding agents, personal agents, and what we're talking about. We call them enterprise agents. That being said, with the appropriate enterprise grade wrapper, these coding agents are perfect candidates to become enterprise agents and participate in the enterprise business process, the agentic process automation. Here's the thing, the way we package these things is actually quite important. This is the last thing I would say. We put all these things in, well, we wrap all this, every agent, Claude Code and such, in a container, microservice in a container.
Yeah.
Once we put it in a container, we can deploy it on the cloud. We can deploy it in a data center. We can deploy it in Kubernetes, which can be deployed just about anywhere, including the edge, including in a restaurant, including in a coffee shop, which, believe it or not, a lot of these places actually have servers out there now. So
Or a mobile or even a mobile phone, right?
exactly. So here's the thing is not only did we talk about the architecture, but we know that all these things can be deployed with technology that is commonplace in many of the enterprises today. I've talked about containers, microservices. I've talked about Kubernetes. These are all things that are used today in enterprises and probably have been used for quite a while. So everything we're talking about, yes, we're mixing and matching new components, but the recipe that we created is something that you've tasted before,
Yes.
which is a beautiful thing.
Right. And even in the forward of your book, I finally got my copy. Uh, it talks about Sean Falconer talks about I think he calls them micro agents because they're built on the microservices architecture idea, which encourages the use of microservices and containers to define those. So, listen, I think it's all coming together, and I think this is great. I think this is a wrap. Is there anything else we want to say about APA for today?
No, this is a wrap, John. Fantastic discussion, my friend, as
Oh,
usual.
okay, stay tuned. More to be learned, more to be shared. And if you like what we're talking about, share this with your friends, like and subscribe, and all of those other things. Thanks for your time.
Bye now.